In this video, we will be discussing a visual way to prove whether a graph is a function or not a function. This technique that we will be talking about is called the vertical line test. Remember, the word vertical means up and down, right? So if you were to draw a vertical line, it would be a line that looks like this. Sometimes you'll see it referred to as the VLT, which is just an acronym for vertical line test. So as we go through this video, if you have any questions, please feel free to pause or replay, because you will be expected to apply your knowledge in class as we continue through the rest of this video. Before we start talking about whether or not a graph is a function using the vertical line test, we need to remind ourselves what a function is. Remember, a function is a set of points or values or a set of things where each x value, so every single x value, has exactly one y value. So there can't be an x that gets sent to more than one y value. Or a shortcut way of thinking about it is that x can't repeat and go to different y values. So you can't have a set of points that would be x comma y, where your x value was 1 and your y value was 5, and then you had an x value of 1, but it gets sent to 7, because 1 cannot have two different outputs. So this would be an example of something that is not a function. Whereas if I had a set of points like 1, 6, 2, 7, 3, 6, notice how none of my x values repeat. So automatically, if none of them repeat, this one is a function. So keep this in mind as we talk about the vertical line test. Taking a look at your homework, you should look at the fact that we are calling x and y the domain and the range of a given set of points. So we know from a couple days ago that the domain is matched with our x and the range is matched with our y. So take a second to graph this first table and pause the video until you're ready for us to continue. Hopefully these are the points that you graphed. If you made an error in graphing, please just correct it before we continue. So looking at this table, we should notice that none of our x values repeat. Once we see that none of the x values repeat, we should know that this is automatically a function. So looking at our graph, we know that yes, this is a function. But what if we didn't have the table and we only had the picture to look at? If you look, if there was, for example, another point, let's say 3, 5, then this would make our table no longer a function because 3 is being sent to more than one location. So I'm going to put that on my graph, 3, 5. You should see that these 2 points, this one and this one, are now stacked on top of each other in a vertical line. But remember, that point was not part of our graph, so that is showing us that there is a function here. So basically, if you can draw vertical lines down your entire paper and only hit each part of the graph once, you know that you have a function. This is kind of like a quick shortcut to figuring out whether a graph is a function or not. Please pause the video to graph the second relation so that we could figure out whether or not it's a function. Hopefully this is the graph that you have on your picture. If you made an error, please just fix it before we continue. So looking at this graph, now you see that at the x value 4, there are two different y values. We can also see that here in the table. This is showing us that, unfortunately, this one is not a function. Because if I were to draw a vertical line down that part of my graph, I would hit the function, and I'm using function in quotations because we know this one is not a function. We would hit this graph twice. The second that happens, we know that this relation is not a function. So keeping this idea in mind, another way to determine if a graph is a function is by using what we call the vertical line test. The vertical line test is what I started to describe up above. So a graph represents a function, so it is a function when a vertical line that you draw on your graph only passes through one point on the graph at a time. So in other words, we can't have what we saw over here happen where one vertical line hits those points twice. Take a second to visualize the vertical line test on this graph. Is this graph a function? Using the vertical line test, I'm going to imagine I drew a bunch of vertical lines down my entire graph from left to right. And notice how every single time I did that, I only hit the graph once. So that means, yes, this is a function. Thinking about the vertical line test again, is this a function? Visualizing those vertical lines again on my graph. Notice how every single time I drew those lines, and I know they're not completely vertical, but you get the idea, I'm only hitting the graph once with each line. So that means, yes, this one also is a function. Is a circle a function? Time when I draw my vertical lines down the center of the function. Unfortunately, at some spots, I hit the graph more than once. The second that even in one vertical line, I hit the graph more than once, that means that the vertical line test failed. And unfortunately, a circle is not a function. So this graph is a little bit of a challenge because we need to remember what an open circle versus a closed circle means. An open circle means that it's not a solution. And you might have seen that when you graphed, for example, the inequality x is greater than 2. If you were to put that on a number line in 7th grade, you would have said that 2 is in the middle, 1 is less than 2, and 3 goes over here. And you would have made an open circle at 2 and shaded to all of the numbers that are greater than 2. By doing that, you're telling me that x has to be bigger than 2, so 2 here is not a solution. That's what this circle here on your graph means as well. It means this point technically is not part of your graph. Everything leading up to that point is, but that point in particular is not really a solution in your graph. So a closed circle means, yes, it is a solution. And thinking about inequalities, x is greater than or equal to 5. If you were to graph that on a number line, you would have made a 5 and then a 4 and then a 6. And you would have taken your circle, colored it in, showing that 5 this time is a solution, and so is anything larger than 5. So keeping this idea in mind, if I were to draw vertical lines down the center of my graph, right, I'm going to hit each point only once, except something strange goes on right here. If I were to draw a vertical line through these 2 points, I would hit both circles. But remember, this circle is not really part of the graph. So because of that, this is really the only point that I am hitting. So when we have open circles, you can count them as the vertical line not really touching them. So in this case, this one actually is a function because it really only hits one part of the graph here, and it only hits one part of the graph everywhere else. So this is what we call a piecewise function, which we will talk about later on in the year. And yes, it is in fact a function. Looking at this graph, I would like you to please finish the following statement without using the words vertical line test as an explanation. So you need to find another way to explain this. I am telling you that the graph of the line is a function because blank. Please describe why this is a function using words other than vertical line test. In this video, we discussed a visual way to prove whether a graph is a function or not a function. This technique that we discussed is called the vertical line test. Remember, if it passes the vertical line test, then yes, it is a function. If it fails the vertical line test, then we know that that graph is not a function. You will be expected to apply this knowledge in class, so please replay if necessary, and please go back if you need another refresher.